I built that model literally in 30 minutes, and you can do it too. Image labeling is a slow and expensive process. However, we needed to train real-time object detection and instance segmentation models like YOLOv8 and YOLONAS. Well, we used to. Autodistill is a new library that allows you to distill knowledge from large foundational models and transfer it into smaller, highly optimized ones. It consists of 6 core elements: task, base model, ontology, dataset, target model, and distilled model. Let's start with task. It decides whether or not Autodistill will automatically build classification, detection, or segmentation model. Depending on the task, you select base model. The base model is a large foundational model that knows a lot about a lot. They are very often multimodal. It means that they can take different types of input, like image and text, and can perform different tasks. For now, Autodistill supports only one base model, GroundedSAM, but support for clip and many more is coming soon. You can also very easily add your own base model and plug it into Autodistill framework. Base models are slow and terribly expensive, too slow to be used in real-time scenarios. However, they are great for automatic dataset annotation. Such dataset can be later on used to train much smaller and faster target model. Models like YOLOv8 or DETR are highly optimized to perform a specific task like object detection or instance segmentation on selected set of classes. To define that set of classes, we need ontology. You can think about it as the recipe that can translate instructions understandable by base model into set of classes understandable by target model. At the end, we just use the dataset created with our base model to train our distilled model. Today we are going to test Autodistill and use it to fully automatically build YOLOv8 model capable of detecting bottles moving on a conveyor. Traditionally, a project like that would require several hours of annotation. However, today we are going to do it end-to-end in less than 30 minutes. Here's the plan. First, we need to create dataset. In principle, to use Autodistill, you only need images. No labels are required. We'll use GroundedSAM base model to automatically create those annotations for us. GroundedSAM is actually a combination of 2 models that we have covered on this channel before, Grounding Dino and Segment Anything model. Grounding Dino is zero-shot object detection model, which pretty much means that it can detect objects on images without any training. SAM, on the other hand, is promptable model capable of converting bounding boxes into segmentation masks. As the result, base model will create fully annotated train and validation datasets that we are going to use to train our target YOLOv8 model. The best thing about it is that the whole process is fully automated. We'll just execute few commands and that's it. Okay, enough of the talking, let's dive in. As usual, we created Jupyter Notebook that I'm going to use during this tutorial. I highly encourage you to open it in a separate tab and follow my instructions. The link to Google Colab is in the description below, but you can also find it in RoboFlow Notebooks repository. First thing first, we need to confirm that our Google Colab environment is GPU accelerated. To do that, we'll scroll to the first cell of our notebook and run NVIDIA SMI command. If everything works as expected, we should see SMI output with details about our environment like driver and CUDA versions. If not, make sure to follow instructions in before you start section. Awesome. Now it's time to set up our Python environment, and to do that, we need to install few packages. Each base and target model has its own repository and pip package. So when you design your Autodistill pipeline, you need to install packages associated with your base and target model. In our case, it's GroundedSAM and YOLOv8. On top of that, you also need to install the base Autodistill package, as it manages the whole distillation process. You can find installation instructions in Autodistill repository, along with the list of supported base and target models. In the end, we just set up our home constant to make it a bit easier to manage paths to videos, images, labels, and weights, and we are good to go. To use Autodistill, all you need to have is a set of images that you want to automatically annotate and use for target model training. We will store those images in images subdirectory located in our home directory. You can see it right now in File Explorer. If you are following along with your dataset, make sure to copy your images directly into that catalog. However, in this tutorial, I will start with a set of video files and show you how to turn it into ready-to-use collection of images. To start with, I have prepared a set of few videos recorded in milk bottling plant. Each video lasts few dozen seconds and shows the bottles moving on production line. All videos are unique and each one was taken at different location and from different angle. Now, all we need to do is to convert those videos into images. To make it a little bit easier, we will use Supervision, one of the packages that we installed during our Python environment setup. Before we will start processing, we'll divide our videos into two groups, test videos and train videos. We'll put two test videos on the side and use them for model evaluation later on. The rest is going to be converted into our dataset. Supervision will open every video, loop over frames, and save every 10th frame into our images directory. Here is a small sample of our extracted images. We can now proceed to the next stage where we auto-annotate that data. That part is straightforward, but a bit time-consuming. As I said in the intro, base models are powerful, but unfortunately a bit slow. Before we start processing, we need to specify objects we want to auto-annotate. I would like my model to detect milk bottles and those small blue caps at the top. I define my ontology and assign milk bottles to bottle class and blue caps to the cup class. Instructions on the left will be passed as prompts to GroundedSAM. If you work with your dataset, make sure prompts are descriptive enough. Depending on your use case, you may need to experiment a little bit. If you want to learn more, make sure to watch our previous videos. We do a lot of prompt engineering experiments there. The links are in the description. Now you just need to sit back, relax, and wait for the base model to auto-annotate your data. Thanks to the magic of cinema, we can skip that part and take a look at the base model results right away. We can see that our dataset got divided into two parts, both containing images and labels. Similarly as before, we can now take a small sample of the images and plot them along with auto-generated annotations. Well, those results look very promising. We are almost there. Now we just need to use our auto-annotated dataset to train our YOLOv8 model. The training process itself is exactly the same like with regular YOLOv8 model. I'm just setting up the starting checkpoint and the amount of epochs. Click Shift-Enter, and we just need to wait for the model to train. Once again, we will just use the magic of cinema and speed up that process. And if you want to learn more about YOLOv8 training, we probably have the most popular YouTube video about it. The link is in the top right corner and in the description below. Now it's time to test our distilled model. Some of you probably remember that at the beginning of the notebook, we put two videos from our dataset aside. We did that to prevent leakage of test data into the training set. Now we can use those videos to evaluate our freshly trained model. This way we can be sure that the model is capable of detecting milk bottles even on video footage that it has never seen before. To perform actual inference, we'll use Ultralytics CLI. We just need to provide two paths, the first leading to our distilled model and the second leading to raw video. The inference result honestly blew my mind. Sure, we have some false positives and false negatives. However, remember, we didn't even spend a second labeling those images. Of course, the effectiveness of Autodistill is highly dependent on specific project. There are some where Autodistill performs flawlessly and can pretty much automate the entire process from start to finish. On the other hand, there are others where Autodistill will need your help. It will auto-annotate the data, but will require your input to clean up auto-generated labels. However, keep in mind that Autodistill is a framework, and with every powerful base model, it will get better and better. Oh boy, I can't wait for GPT-4 image input to be released so that we can finally see how well it handles automatic image labeling.
So remember, GPT-4 is not just a language model. It's also a vision model.
In the meantime, make sure to test Autodistill on your dataset and let us know in the comments which base and target model should we support next. You can find the link to Autodistill GitHub repository in the description below. And that's all for today. If you enjoyed the video, make sure to like and subscribe and stay tuned for more computer vision content coming to this channel soon. My name is Peter and I see you next time. Bye.